Let's do one more problem in section 6.2. Find the volume of the solid obtained by rotating the region bounded by y equals 8, x cubed, y equals 0, and x equals 1 about x equals 2. Let's draw a graph. Y equals x cubed. So the graph should look like this. This is y equals 8x cubed. And we think about x equals 1. And the axis of rotation is x equals 2. The region we are thinking about is bounded by this curve y equals x cubed and this x-axis, which can be described as y equals 0 and x equals 1. This one. So we are thinking about this area. Axis of rotation is x equals 2. So we rotate that area, triangular part, around this vertical line. So when we think about the cylinder, we are rotating the horizontal cylinders, which are perpendicular to this the vertical axis. So these sticks will be rotated around this vertical line. So we can say that this part, small part, can be related to delta y, and the inner circles, the inner circle's radius is 2 minus 1, which is 1. And outer circle's radius is this is the outer circle's radius. is we have to subtract from here to here, but we are thinking about dy. So we have to convert this equation into y-related equation. That means we will solve for x. We divide by x on 8 on both sides, then we get x cubed equals y over 8. And when we do 1/3 power on both sides, it'll be cubed root of y over cubed root of 8. 8 is 2 cubed, so these two cancel each other. So we have cubed root of y over 2. Right? Could you please activate your camera? I feel like I'm talking to myself. Thank you. So outer circle's radius becomes this distance minus this distance, which is 2 minus 1 over 2 times cubed root of y. Let's establish the formula. The volume is from dy, so we have to figure out y range. We figure out this intersection point. This is x equals 1. And so that is 8, right? Because at the intersection point, x value must be 1, right? So when we look at this graph, when x equals 1, y equals 8. One cubed is 1, right? Any question about this? Okay, so it becomes 0 to 8. In principle, that is outer disk area minus inner disk area dy. So that is from 0 to 8 pi r squared. We already calculated this r and this r. So pi times r squared of outer circle's radius, which is 2 minus 1 over 2 cubed root of y squared minus pi times inner circle's radius 1 squared dy. So we want to calculate this part first. Two minus 1 over 2 cubed root of y squared is I'm using just a minus b squared is a squared minus 2ab plus b squared. or you can do FOIL if you want. So the first one squared is 4 minus 2 times 1 over 2 times 2, 2 times multiplication of these, and the cubed root of y plus this one squared, which is 1 over 4 cubed root of y squared. Right? So when we simplify, this will cancel each other. This can be written as y to the 1/3 power, and this can be written as y to the 2/3 power. This is in the denominator in the power, and this is just in the numerator in the power. So that becomes 4 minus 2 times y to the 1/3 power plus 1 over 4 y to the 2/3 power. So that is pi times integration 0 to 8. Because this pi and this pi in the second term can be regarded as common factors, so I'm taking out. And then the first one squared, which turned out to be this. So 4 minus 2 times y to the 1/3 power plus 1 over 4 y to the 2/3 power minus 1 squared, which is 1 dy. That came from here. And then we have pi times integration 0 to 8. 4 minus 3, 1 make 3 minus 2 times y to the 1/3 plus 1/4 y to the 2/3 dy. And then pi times integration according to y, so 3y minus 2 times 1 more power, so 4/3 over 4/3 plus 1 over 4 y to the, we add 1 here, so that is 5 over 3 divided by the same power, 5 over 3, from 0 to 8. We use this principle, a over b can be written as a times 1 over denominator, so reciprocal of the denominator. So this can be written as pi times 3y minus 2 times this is the denominator. When we just multiply in a common way, then we have to flip and multiply, which means 3 over 4 times y to the 4/3 plus 1 over 4 times we multiply the reciprocal, so 3 over 5 y to the 5 over 3 from 0 to 8. So here 4 is 2 times 2, so the 2 will cancel each other. And we plug in number, so pi times 3 times 8, let's say 8 equals 2 cubed. So 3 times the first one, we just write 8 minus the second term is a 3 over 2 times 8 is 2 cubed 4/3 plus third term is 3/20 times 2 cubed to the 5th power. Right? The 5/3 power. So we know AM power times n power is a times m times n. So we just multiply the power. So these three will cancel each other. So we get pi times 24 minus 3/2 times 2 to the 4th power, which is 16, plus 3/20 times 2 to the 5th power, which is 32. And then all the complicated part of the calculation is done, and the mechanical calculation should be performed until you get 24/5 pi. I will not go through the mechanical calculation. That is the last problem in this section. Six point three is about volumes by cylindrical shells. Before we move on to 6.3, let's just review what we did in the previous section for disk method. So we have an object. With the disk method, what happened was if we rotate around y-axis, then we drew the sticks, which is perpendicular to the rotational axis, right? And then we turned this stick around y-axis. If we turn around the x-axis, then this is the rotational axis, and we drew the stick which is perpendicular to this rotational axis. So this axis will be turned this way, right? Different from this disk method, when we think about the volumes by cylindrical shell method, when we know the rotational axis, we rotate the sticks which are parallel to the rotational axis around that axis. Let me explain. Let's consider the graph which looks something like this. This is y equals f of x. And we want to think about rotating this region from A to B. around y-axis. As I said, in the cylindrical shell method, we will rotate the stick which is parallel to this rotational axis. So we will draw this vertical stick. And then we will get the cylindrical shell, cylinder. So what happens here is when we rotate this kind of stick around the y-axis, we will have a cylinder whose inside is empty. So it looks like this. And then this is height. Let's say this radius of the smaller circle is R1. This radius, which is from the radius of larger circle, is written as R2. Here is the circle in the middle. Let's say that is R. Then that will average smaller r and larger r. So r equals R1 plus R2 over 2. Average. We want to think about the volume. When we think about the volume, what we do is we just cut vertically like this and unfold the object. Then it'll be something like this. This is just the stretch the inside a little bit and the shrink the outside a little bit, and then we can think about the cylindrical object. This is R, and this time this is H. And this one, thickness, can be denoted by delta R. So this thickness can be denoted by delta R. So this is not R. So the we unfolded the this circle. So this is 2 pi R, which is circumference. So the volume of this cylindrical object is V equals 2 pi R H times delta R. This is volume of cylindrical shell. Cylindrical shell. The radius for the outer circle is given. I don't calculate anything. So from here, we are forming the volume formula. So volume V equals integration. So this is delta R, which is delta X. And this is H. So H is determined by the function And the R, in this case, if we are thinking about this graph, then that is just a distance between here to here. And this thickness will be almost zero. So we just say this is R. And that corresponds to X value, right? So the formula will be established as A to B, 2 pi R, which is circumference, times height, which is f of x, times thickness of the cylinder. So that is the formula for the cylindrical shell method. And you have to remember that clearly. Make the formula sheet and summarize all the formula you're learning so that you're not confused with during the exam hour. Formula will not be given. Find the volume of the solid obtained by rotating about y-axis the region bounded by y equals 2x squared minus x cubed and y equals 0. To figure out the strategy, we have to figure out the graph first. For y equals 2x squared minus x cubed, we take out x squared, then 2 minus x. When we factor, the rough graphical shape looks like this. The x-intercepts are 0 and 2, obviously. What the problem is suggesting you to do is find the volume of the solid obtained by rotating about y-axis. So like this. We use cylindrical shell method. This is y equals 2x squared minus x cubed. So we are drawing the sticks, which is parallel to the axis of rotation. That's important. In the shell method, the radius is the distance between this rotational axis and this stick, which is just the x value. And this is delta x. And this is a y, right? So we're thinking about the cylindrical shell. So we have to think about circumference. Circumference is 2 pi x, the radius, and height is f of x dx. The x ranges between 0 and 2. So 0 to 2, 2 pi x times f over x is 2x squared minus x cubed dx. So we take this out, so 2 pi from 0 to 2, and then we distribute. Then that is 2x cubed minus x to the 4th power dx. So that is 2 pi times 2 times this one more power, x to the 4th power over 4 minus x to the 5th power over 5 from 0 to 2. So these two will cancel each other and the denominator will become 2. Let's plug in the number. Then that becomes 2 pi, 2 to the 4th power over 2 minus 2 to the 5th power over 5. So this one will become 2 cubed, which is 8. So 2 pi times 8 minus 32 over 5. So that becomes 2 pi times 40 over 5, because 8 over 1 multiplied by 5 to the numerator and denominator will make 40 over 5 minus 32 over 5. So it becomes 2 pi times 8 over 5, which is 16 pi over 5. Any question? Let's do the next problem. Next problem is find the volume of the solid obtained by rotating about the y-axis, the region bounded by y equals square root of 25x and y equals x squared over 25. Let's visualize. For this one, this is just a 1 over 25 times x squared, which is parabola. In the problem, it suggests to rotate around the y-axis and use the shell method. So let's just draw the right half side of y equals 1 over 25 x squared, because we are thinking about another graph which will be located on the right side of the y-axis, because square root of something is always positive. Obviously, the graph should look like this. This is y equals square root of 25x. So we think about this range. We think about the cylindrical shell method with the rotational axis, y-axis. So we draw the cylindrical, this vertical stick like this. Then the distance between this y-axis and this stick is x, and we think about delta x. So what we have to think about the height will be this is a height. If you look at this graph is higher than this graph, right? This is lower and this is higher. So height will be square root of 25x minus x squared over 25. We are thinking about delta x, so we have to think about the intersection, x coordinate of the intersection point by making these equal. So we are thinking about this point. This is apparently 0, right? So we put the equation x squared over 25, this one, equals square root of 25x. We want to eliminate the square root. So we will square on both sides. In this section, we are dealing with the cylindrical shell method. So when they're asking you to solve the problem, the premise of that is using the cylindrical shell method. But in this problem, what I will do will be, after I solve the problem by using the cylindrical shell method, I will demonstrate the solution by using the disk method. So two methods can be applied. In the exam, if I give you an exam problem, then I will give you an instruction about whether you have to use cylindrical shell method or disk method. So let's square both sides. Then that'll be x to the 4th power over this one squared is 25 times 25. Right side is 25x. So we multiply by 25 times 25 on both sides. So x to the 4th power equals 25 cubed x. So x to the 4th power minus 25 cubed x equals 0. X is the common factor, so x cubed minus 25 cubed equals 0. So x equals to 0, or x cubed equals 25 cubed, which means x equals 25. So intersection points are 0 or 25. So here 0, this is 25. Let's calculate the volume by using the cylindrical shell method. X ranges from 0 to 25. 2 pi, I said the radius is x, 2 pi x times the larger one is a square root of 25x, and smaller one is x squared over 25 dx. This one is 25 square root of 25 times square root of x, which is 5 times x to the 1/2 power. So let's put 2 pi outside of integration 0 to 25. This one times this one will be what? 5 times, this is 1 power, and x times x to the 1/2 power is x to the 1 power times x to the 1/2 power. So x to the 1 plus 1 over 2 power. So x to the 3 over 2 power. The formula I used was a to the m power times a to the n power is a to the m plus n power. 5 times 3 over 2 power minus x, we distribute like this. So x cubed over 25 dx. So we integrate 2 pi times 5 times 1 more power, 5 over 2 divided by 5 over 2 minus 1 over 25. And 1 more power is x to the 4th power over 4 from 0 to 25. So we get 2 pi. 5 times the denominator can be flipped and multiplied in front of the fraction. So times in front of the numerator. The x to the 5 over 2 minus 1 over 100 x to the 4th power 0 to 25. So we cancel 5 out. Then we have 2 pi times 2 x to the 5 over 2 power minus 1 over 100 x to the 4th power 0 to 25. Let's evaluate. Then that is 2 pi times 2 times 25 to the 5 over 2 power minus 1 over 100 times 25 to the 4th power. So for this part, this one 25 is 5 squared and 5 over 2 power. Those two will cancel each other, and that is 5 to the 5th power. After you get this, the remaining step is mechanical step, which I don't like to go through. Then you will end up getting 9,375 pi over 2. In this problem, we can apply the washer's method. Let's draw the same graph. This one comes from y equals x to the x squared over 25. And this graph was y equals square root of 25x. We rotate around y-axis. Then in this case, we already calculated 25, this intersection point. When that is 25, 25 times 25, and square root is again 25, right? Y-intercept is 25. This time we are using the washers method. So the kind of sticks we draw will be perpendicular to this rotational axis, which means we have to draw the horizontal sticks. This is for y equals this object, y equals square root of x, and another stick is for the rotation of the outer circle. So we will get different type of just a cylinder, steel cylinder with the middle part is empty, but the cylinder this time will be very short cylinder. So this is dy, delta y. And the radius of the inner circle is y squared of 25, because this is just distance in x coordinate. And the radius of the outer circle that is 5 square root of x. So if I give you the volume formula in this case, then we are thinking about delta y. So we have to determine the y range. So y range is between 0 to 25. And outer disk area minus inner disk area times dy. So the equation we have to set up will be 0 to 25 pi times 5 square root of y x y squared minus y pi times the y squared of over 25 squared dy. So this is x, and so this was y. So this one, if we square this, then that is y squared equals 25x. So x is y squared over 25. So outer circle's radius is inner circle's radius is y squared over 25, and outer circle's radius is 5y squared, square root of y, because we solved this for y. So x squared equals 25y. So x equals plus or minus square root of 25 square root of y. But we are thinking about the right side, so that is just positive. And also we are thinking about radius. So 5 square root of y. So that is how we got this one. So that is pi times integration 0 to 25. That is 25y minus y squared, y to the fourth power over 625 dy. And then we integrate, so pi times 25 times y squared of 2 over 2 minus 1 over 625 y to the fifth power over 5 from 0 to 25 and so on. And then you will get the same answer, 9,375 over 2 pi. If you have question, then you can ask me question, but otherwise you can leave. Yeah.
Miss Kwan,
Yeah.
when will you be posting the lecture?
Maybe within 30 minutes.
Okay.
Any other question?
Thank you. Have a good one.
You too.